as we wrap up our section on polar equations, I'd like to make a quick video to just show you some common polar graphs and how you might graph them on your calculator. So first things first, when we're dealing with a polar equation, we're going to go to our calculator here. I'm going to go ahead and click Mode. We want to scroll down to where it says function. Now, normally our calculator is in function mode. And when I'm in function mode, if I hit y equals, I get y, and I push my variable button, it gives me x's. Now, going back to mode, going back down there, I'm going to scroll over to parametric, skip that one, because we're going to talk about polar. We do talk about parametric later in semester. So polar is my third option. I'm going to hit enter to select polar. And then now what happens when I hit my y equals is I have r. And if I push my variable button, you'll notice that third variable option there, it's giving me theta. So I've got r in terms of theta. Now, keep in mind that I'm in radian mode. So this will make a difference, especially when we're using our window. If we wanted to change our window, because we need those theta values to fall between, say, 0 and 2 pi, pi being 3.14, 6.28 is double that, 2 pi. And then we'll talk about this theta step. You don't need to worry so much about the x-min and x-max, but you may want to change those just to zoom in or zoom out properly. So let's look at this. First things first, I'm going to go ahead and just graph this first one. R equals 1 minus sine theta. So I'm going to come over here, 1 minus sine of theta. Close my parentheses. I'll hit graph. Now I'm zoomed strange, so I'll hit zoom 6. And I get this graph that looks a little bit like a heart. Cardioid, cardio in there. So I can't see this graph very well. One thing I might do would be to zoom and then choose option 2 to zoom in. So I'll scroll down a little bit. So I zoom in kind of at the center and I'll hit enter to zoom in. You can see that heart shape a little bit better. One thing we want to note is that this is not a square window, meaning that distance on my y-axis, counting 1 unit, is smaller than the distance on my x-axis. So something that really helps us when we're trying to visualize these will be to choose option 5, zoom square. And this is what the shape of that cardioid looks like. One thing also, when we think about that window, we want to make sure we're graphing from 0 to 2 pi. If I change this to, say, 1 pi, 0 to pi, when I scroll down, that will turn to 3.14. How much of my graph have I drawn? I started at 0 and it drew the graph till it got over here to pi, right? So this would be 3 pi over 2 and then all the way around to 2 pi. So if you want to see that full polar graph, you want it to go from 0 to 2 pi. And talking about the theta step, that's just how many thetas is being calculated. You can make this a small value. I suggest not making it any smaller than 1,000th. That means it's going to do 6,283 calculations. So if I hit graph, you'll notice it's drawing much slower because it's performing a lot of calculations to make a smooth graph. Now, if you do get into a situation where it's drawing and you want it to stop, you can just hit the on-off button. That will stop your graph and let you exit the screen. If you hit the enter button, the enter will pause the graphing, but on-off will stop it. So I think that's graphing too slow. Maybe I want to graph by units of 1. Now, that doesn't look very smooth. Well, that's because it calculated 1, 2, 3, 4, 5 points, because there are 5 whole values between that 0 and 2 pi. So one thing we also want to make sure we do, is just have that theta at around 1/10 or 100th. That'll give you a nice, fairly quickly drawn graph. So this is the shape of a cardioid. If I was in Zoom 6, I wouldn't be getting that nice window. Let's look at what a rose looks like. So that's r equals 4 cosine of 5 theta. So go to my y equals, clear that out. R equals 4, and I had times cosine of 5 theta. So I've got cosine 5 theta, close my parentheses, hit graph. You see this looks slightly like a flower. Now if I hit zoom, say 5, it'll be a little bit more square. Notice this is a 5-petaled rose or flower, and we've got that 5 theta in there. Now it's not very smooth. I could also zoom in and let's see, I'm looking up here. I've got 1, 2, 3, 4, 5, 6. I think about 6 units. 1, 2, 3, 4, 5. 5 or 6 units to the left and right. So I'm going to go and change my window here. And say maybe my x's, instead of going from negative 15 to positive 15, go from, I don't know, negative 8 to positive 8. And then my y values go from negative 5 to positive 5. We can see that rose. You'll notice it's not super smooth. So if I wanted to make it a smoother curve, I would obviously make this number here a little smaller. Let's try 100th, which is going to be 628 calculations. Now you see a much smoother rose. So graph that rose from 0 to 2 pi. It made it a little bit smoother. I might not be square anymore, so I'll hit zoom 5. Now I've got a perfectly square graph, and I've zoomed in on it nicely so I can see how it looks. The last one we'll graph is called a lemniscate. Lemniscate is the vocabulary word, which means the infinity symbol. So that's what a lemniscate is. So I'll come over here. R equals, what do we have? 2 cosine 2 theta minus 1. 2 cosine 2 theta, close parentheses, minus 1. Look at our graph. Since I've already set my window nicely, I get this nice smooth graph with these 2 infinity symbols in it. So anyhow, those are some common polar graphs you'll see. A cardioid, which is kind of a heart shape, a rose, which is obviously a flower, and then lemniscate, which has these infinity symbols in it. So I did that off the cuff, and I hope I couldn't pause or edit while I was working, so I hope everything sounded okay. If you have any questions or you need extra help, just let me know. I'm happy to, make something else to support you while you're learning. So graphing polar with your TI calculator.